So this time, we're gonna have to think about the applications in our field. So consumer surplus and producer surplus are used all the time. Two graphs, both are the price functions, but one represent the demand or the price that the consumer willing to pay, right? And the or the available on the market, and the supply function, that is the graph or the function for the producer. Okay, the producer, the consumer, and wherever they meet each other, that point is called the equilibrium point. And how to find? We just equate S and D together, or demand equals supply. So demand function equals supply function, and then we're gonna solve for X. And that X is called the equilibrium point. And the X equilibrium point, whatever the function you replace X into, either the supply or the demand function, you're gonna get the same price. The price that those two like meet in between. Okay, so from this situation, at the equilibrium point, this is the price that both like happy, like consumer happy and the producer happy. So gonna be we're gonna draw the line, which is the line of the y equals the price that occurs at the equilibrium point. And then from the area between the demand and supply curve, that's supposed to be the entire area here, right? But if you break it as the area above the equilibrium point, no, above the equilibrium price, that area is the extra area that's beyond the market price that the consumer are willing to pay. So that's why that area represents the consumer surplus. So that means that's basically they are willing to pay more than the market price. So that area represents the consumer surplus, where the other area, which is the area below the equilibrium point or equilibrium price or the market price, so that is the price that the producers happy to get, or basically that's the additional income or additional revenue for the producer, because the curve, the down here is a supply curve, which that's the real curve, the real price, the real cost that they can do. But above here is the line that's beyond what they can expect. So that means this is the additional revenue that the producer can make. So going to be two parts, one for the consumer surplus and the other one is the producer surplus, combined as the area between the demand and supply curves. And the demand and supply curves, they meet each other at the equilibrium point. Okay, so from this concept, we're going to use the definite integration to compute the consumer surplus. We use the notation like CS from consumer and S from the surplus, and the producer surplus, the PS. And how do you set up? The setup is for the consumer surplus, as you see, that's the above part of the entire bounded area. So that's going to be the total. That means for the whole thing, that the value that the consumer are willing to pay, and then subtracted by the cost that they actually pay. So when you subtract the yellow part and the blue part here, that becomes the additional one, that is the consumer surplus. So when you set up, gonna be the demand, which is the top curve here, subtracted by the product of the equilibrium point and the price, which means the rectangular area here. So this is the length, this is the width, that's the area of the rectangle. And the rectangle, that is the quantity for the total cost that the consumer actually pay. And then for the producer surplus, Similar way, but now it's based on the supply curve and the market price. So you find the total area, set up the definite integration. That's the total value for the producers, and then the total cost to the customer, that is computed the same way as the X times P, which is the equilibrium point X times the price or the market price. And then you subtract these two area together, the area A and the area B here. So you see the additional area. As a picture, you can see that the rectangle is greater, the area of the rectangle is greater than the area in yellow, which is the area below the supply curve. So the difference when you set up, you're gonna set up the area of the rectangle, which is the product of the equilibrium point and the market price, subtracted by the definite integral from 0 to xe. You see xe is the equilibrium point of the supply function. So you're going to use the supply function to compute the producer surplus. Use the demand function to compute the consumer surplus. Okay. It sounds confusing, but when you see the graph, it's very clear. And also for some problem, they just ask you to do one thing, not do both. So just think about the way as a common sense way to compute the consumer surplus and the producer surplus. Okay, let's get started with the first example here as the application. All right, so I will go slow, and you can stop me anytime if you need help, okay, or need more explanation. For this one, number 3, let's highlight the term. The demand function for the particular product given by dx equals 24 minus 0.6x minus 0.03x squared. And the equilibrium point is 10 units. We're going to find the consumer surplus. For the graphical way, the demand function is coming down. And then there will be the market price. Okay, so that is the equilibrium point. So this one is the demand or the dx. And at this level, it occurs at xe. And xe for this problem is 10. Okay, so we're going to find out what is the consumer surplus, which is the additional area there. To set up, I'm going to write it as the CS. So CS as consumer surplus. Consumer surplus equals, and I put here as the total area, which is the definite integral from the point 0 to the equilibrium point of the demand function with respect to x, subtracted by the additional area, not the additional area, the area of the rectangle, which is the area that's based on the length and the width from the equilibrium point or the 10 units. And the height here is supposed to be the d at the equilibrium point, which we don't know yet. Okay, so that is the area of the rectangle. I'm going to write it as a formula, as a quantity, xe times d at xe. Okay, so from here, we know that I'm put on the note here, the xe equals 10. So we know that the upper limit here going to be 10. We know that dx as 24 minus 0.6x minus 0.03x squared. And how about the d at xe? We don't have it yet. So we're going to compute on the side notes here. So d or the demand at 10, which is the d at xe, equals, plug it in the formula that given to us, 24 minus 0.6 times 10 minus 0.03. Yes, let me clean up, write it in the better notes. Where did it go? Don't go away. So we're gonna find the price, the market price basically. So this is x at 10. So this is 10. So equals 24 minus 0.6 times 10 minus 0.03 times 10 to the second. And then put in the calculator real quick. So what we have, let me see what we have here. You guys can help me find that number or check the number for me real quick. So I'm gonna put in the calculator real quick and then get back in a little bit.
I got 15.
You got 15? Okay, that sounds right. So, yep, I got the same 15. So everyone agree? So we have 15 here. So that means this number gonna be 10 multiplied by 15. Okay. So that means our problem or definite integral is from 0 to 10 of the 24 minus 0.6x minus 0.03x squared with respect to x, and subtracted by this one is the price times the equilibrium unit. So what we have to do next, just do the routine work as finding the antiderivative for the first part and then subtract it by 10 times 15, which is 150. And whatever the number, that is the consumer surplus or the value that the consumer will save based on this information. So the first one, we use the constant rule. We got 24 times x. The second one, the constant multiple 0.x. The power, this is the power 1, going to be 1 plus 1, which is power 2, divided by 2, minus another constant multiple 0.03 times x to the third over 3. Evaluate from 0 to 10 and then subtracted by 150, which is the product of 10 and 15. And what we have to do next, you just have to clean up. That what I would recommend you to do. Simplify before you do the evaluation. So it's going to be 24x minus 0.3, starting to act weird. So let me say it before it goes away. The middle term reduce the 0.6 and 2 become 0.3 x to the second. The third term becomes 0.01 times x to the third. And then we're going to replace the x with the 0 and x with the 10 and subtract by 150 after that. Okay, so evaluate at 10. So 24 multiplied by 10 minus 0.3 multiplied by 10 squared minus 0.01 multiplied by 10 to the third power subtracted by 150. Oh, another group I have to replace with a 0, right? Be 24 times 0. Almost forgot. For this case, if I forgot, I'm still okay because 0 times anything, you're going to get 0. So it doesn't hurt. So for this case, if I forgot this part, so I'm still okay. I got lucky, huh? So what we have here, this is 240. You can put in the calculator to help me out if you could. So this is 0.3 times 100, so it becomes 30. And this is 0.01 times 1,000, so it becomes 10. I believe 10. 1, 2, 3, yeah. And then the number comes out to be
I got 200.
200. Okay,
Yeah.
that's good. So I got the same. So 200 minus 150. That means the number comes out to be 50 as the value that the consumers will save or the consumer surplus.